Hey, good morning, everyone. My name is Riya. I'm a senior product manager at Azure Kubernetes Services. And today we're going to take a deep dive into securing Azure Kubernetes across the full stack. In this session, we'll walk through a layered security model, covering everything from image and supply chain security to node hardening to runtime and application level protections. The goal is to show you not just what AKS offers, but how to holistically think about security in your Kubernetes environment, how to reduce risk, respond to incident faster, and protect your workloads in production. All right, let's ground this conversation in reality. If you follow the cybersecurity news, you may have seen some of these articles. These aren't just hypothetical risks, they are real-world attacks, and they are increasing both in frequency and sophistication. So as you can see, from supply chain to privilege escalation, attackers are constantly probing for weaknesses in containerized environment. And when breaches do occur, they often go unnoticed, especially in ephemeral and fast-moving workloads like containers. So as adoption grows, so does the attack surface. So things like supply chain dependencies, APIs, service mesh, workload identity all introduce new attack vectors. And meanwhile, attackers' capabilities have also scaled. They're enhancing. So we now see automated bots, vulnerability scanners, and even AI-driven fuzzing tools aimed at Kubernetes clusters. And if you think about it, most breaches aren't due to 0 days, but they're due to misconfigurations, lack of defense in depth, or overprivileged identities. And that's why we need to take a holistic approach in securing our containerized workloads. So not just securing one layer, but thinking about how do we achieve a defense in depth approach and secure AKS across the full stack. All right, now that we've seen the why, let's talk about the how. How AKS helps you defend against threats at every layer of the Kubernetes stack. And Kubernetes security isn't just a single toggle or a feature that you can enable, but it's about a defense in-depth approach where you need to protect multiple components across every layer that make up your workloads. So AKS provides built-in capabilities and integrations to help secure container and image. This is to protect against vulnerable or tampered container images, control plane and Kubernetes objects, where role-based access controls, admission policies, and API security comes into play. Nodes, which is the underlying infrastructure, where kernel hardening, OS security patching, and isolation matters. And lastly, application and network, where you need to think about runtime protection, egress-ingress controls, and much more. In the next couple of slides, we'll break down each of these layers one by one. We'll also talk about some of the existing capabilities that AKS offers to help secure your Kubernetes environment. And also we'll discuss some of the new additions or capabilities that have been recently introduced to help you raise the security baseline of your AKS infrastructure. All right, so starting with securing containers and images. So the foundation of your Kubernetes workload is the container image. If the image is compromised, everything that runs from it is at risk as well. So this layer is all about proactively securing what you build and pull. So we are not just reacting to threats at runtime, but we are also striving towards stopping threats from entering the cluster in the first place. AKS integrates with Microsoft Defender for Cloud, and we'll go over all of this in detail in the next couple of slides as well. But just to highlight a couple capabilities with Microsoft Defender for Cloud, we have container image scanning, we have runtime scanning and threat analysis. to identify any like emerging threats that are going around in the real world. Then we have image integrity that helps ensure that you're only running what you trust, you're only pulling container images that are signed and come from a trusted authority. And lastly, capabilities like image cleaner that help keep your environment free from any abandoned or unused container images that may have tons of CVEs. All right, so I just want to take a step back and maybe reference what Nick had talked about with the growing AI adoption. So if we think about it in today's AI landscape where cloud native applications are being developed and deployed faster than ever before, the attack surface and security risks are also growing with the same speed. And this is where we need to ensure that we have enough controls in place to help detect or identify security issues in near real time. And that's where Microsoft Defender for Cloud steps in. That provides comprehensive code to runtime security. So starting with, we have secure development, where MDC prevents vulnerabilities and misconfigurations at development time. So thinking about shifting left, this is where you're developing, building your container images, and MDC helps here scan for CVEs in those container images or any dependencies that you use in building your container image to help ensure that you are only deploying or you only have secure application configurations. Second comes the contextual posture management. So MDC also helps you prioritize and continuously reduce the attack surface, speed up any security remediation cycles, and allow you to stay ahead of any emerging threats. We're going to talk about some of the capabilities where this comes into play in the next slide. But the risk level for security findings by MDC is dynamically calculated based on the attack path analysis. So thinking about your workload, do you have RBAC enabled, or is it open to the internet? So MDC takes into account all of these things in detail before it gives you its findings or a risk level for some of the security issues that MDC identifies. Then completing the cycle with runtime threat protection. MDC also helps protect your applications against ongoing attacks with near real-time detection in a unified investigation and response experience, which again, we'll discuss in the next couple slides. Just to lay out some context for what's upcoming, just want to discuss, or take a look at the entire supply chain. So when we start from code, this is where you're developing, to build, where you're building your container images, then shipping those or pushing those to the container registry, deploying those container images to your AKS clusters, and finally, those images are running inside your cluster. So Defender for Cloud helps customer protect throughout the application software development lifecycle. So starting early with the CI/CD pipelines supporting multiple integrations with ADO, GitHub, GitLab. At the very left, at the build and the coding stage, it provides security controls to help scan and prevent the creation of vulnerable container images. Then moving to your container registry with a periodic vulnerability scanning, and from there into your clusters where Defender can notify and prevent the deployment of any vulnerable container images. MDC also helps customers identify any security gaps in their clusters, as well as identify any exploitation attempts at runtime. And all of this can be viewed in the Defender portal, in the AKS security dashboard, or by using the MDC public API. With that, I'm excited to announce the general availability of AKS security dashboard that provides comprehensive visibility and automated remediation capabilities for security issues that MDC identifies, empowering you to easily and more effectively secure your Kubernetes environment. So you are able to review, investigate, and get a guided remediation for any runtime detection threats, vulnerability assessment, or misconfiguration and compliance standards. So as you can see, that we have key categories here with vulnerabilities and compliance issues and any misconfigurations that are based off of certain security best practices. That all is identified by MDC, and it also gives you a risk level rating, high, medium, low, based on the attack path analysis that I mentioned. You can enable Defender for Containers plan and configure settings for specific clusters. One of the flexible solutions that MDC offers is that you can assign an owner to some of the security findings to track the progress of a security issue, so the owner could investigate or mitigate the security issue based on the analysis. All right, so now let's shift the focus to the control plane, which is the brain of your cluster, and the Kubernetes objects that define your workloads. And this layer is often overlooked because it feels managed, but it's actually where most governance, identity, and access decisions happen. And AKS offers a strong security baseline for the control plane out of the box, and customers can build on top of it using features like private cluster, API server authorized IP ranges to reduce the attack surface of the control plane, managed cluster identity that basically makes it easier to access Azure resources securely, KMS encryption and custom certificate authority support to ensure that your etcd data and certificate meet certain compliance requirements that you may have within your organization. And lastly, governance is ensured or enforced through Azure policy to make sure if you have certain configurations or rules that need to be followed for your Kubernetes workload, you can configure those policies through Azure policies and ensure that your workloads meet those requirements. Lastly, identity and access management using intra-auth and authorization. So these are like some of the capabilities that we have already existing, but just wanted to go over those to recap on what we have for securing the particular layer. And then let's go over some of the additional capabilities that have been introduced. So I do want to point out that security has been the top priority for Microsoft and for AKS. And we are investing a lot in secure by default, secure by design configurations, where we want to ensure that security is embedded in the product and there are controls applied by default to add an additional layer of protection. So with that, we have kubelet serving certificate rotation that is enabled by default in your AKS clusters. So just to recap, kubelets are the agents that exist on each node that connect your nodes to the control plane, and they serve a cert that proves the identity of the nodes. So with kubelet serving cert rotation, AKS rotates the certificates issued by the cluster CA automatically using the Kubernetes native bootstrapping. This means there is a tighter trust boundary between the node and the control plane. There is less operational overhead on teams to manage the certs or rotate the certs regularly. And this is also in alignment with the CIS Kubernetes benchmark, where we now set the rotate kubelet service certificate to true for the compliance requirement. So in short, We have stronger node to control plane trust enabled by default with no effort from the customer's end. It only happens since it happens during the bootstrapping time. There is like slight downtime that is involved with the bootstrapping.
Can you repeat what he asked?
The gentleman there asked if there's any downtime with this. So since it's part of the bootstrapping, there isn't a lot of downtime, but it's just involved with the time it takes to bootstrap your nodes, as you know, in the regular basis. So next up, accessing private clusters or even clusters with strict API server IP ranges has traditionally been a challenge. It requires you to set up VPNs, jump boxes, or managing complex network routing to tunnel into the cluster. So we are changing that with the new Azure Bastion integration, which is now in public preview. This drastically reduces the operational complexity and overhead that you have while accessing the private clusters, so you do not need any VPNs or jump boxes or any public IPs. You could configure Azure Bastion in a couple simple steps. So you can create Azure Bastion subnet in your AKS virtual network, create either a premium or a standard SKU Bastion in that subnet, and then simply use the AZ AKS Bastion and pass your cluster and Bastion details to open the Bastion tunnel to easily connect to the private, to your AKS cluster. So this makes enforcing private clusters or private access to the clusters more practical, and therefore also helps with ease of adoption for private cluster or API server authorized IP ranges. All right, next up, manage namespaces. As you may know, namespaces are a way to separate resources logically. You could group like certain teams, services, or applications to a namespace. And however, if you think about it, these namespaces are just labels, and they don't really enforce things like CPU or memory limits, network policies, and these are not provided out of the box with the namespaces that exist natively with the Kubernetes environment, but it does require setting up a lot of processes and script to create or set up resource memory limits or network policies or grant proper RBAC. With managed namespace being in public preview, we aim to close that gap. So with managed namespaces, you have the capability to utilize the built-in network policies, where you can simply define the ingress, egress, traffic rules to control how traffic flows to and from your workloads. You can set up CPU memory requests or limits, and by setting these quota limits, you can prevent resource overuse and maintain cluster stability. Then you could also set up or configure labels and annotations that are attached to the Kubernetes objects, which in this case is the namespaces, to provide additional metadata. So labels can be used to organize or categorize teams, applications, while annotations can be used to store like any non-identifying metadata that can be used by other services or tools. There are also options available to make changes to the existing namespaces, which we will go over.
Kubernetes namespaces can be set up in the Azure portal. In the search bar right up here, by simply typing in managed namespaces and hitting the service once it pops up. Let's go ahead and try to create a new managed namespace. We can see that we can select which subscription we want to create our namespace in, and select one of our existing clusters if we want to do so. I'll select this one that I've made previously, and please do note that your clusters must have the Azure RBAC row enabled. Next, we have the ability to either create a new namespace, or in this case, I'll choose to convert an existing namespace to a managed one. I've already made an unmanaged one, and I'll go ahead and convert that for this process. You have the option to configure some ingress and egress networking policies, along with setting your requests and limits for your compute quota. Finally, on this page, you can configure the access permissions for teammates who might need to use the namespace. You can configure labels, annotations, and tags for your managed namespaces. Once you're ready, hit review and create, and if everything looks good to you, you can go ahead and create your managed namespaces. We walked through creating managed namespaces in an existing cluster, but you can also go ahead and create a managed namespace in a new cluster by heading over to the Advanced tab and configuring your managed namespaces. Likewise, if you are setting up an AKS automatic cluster, during the cluster creation process, head over to the Advanced tab and configure any managed namespaces you would like.
All right. So now that we've covered the control plane, let's move down the stack to one of the most critical areas, which is the node layer. This is where your workloads are actually running. So securing the host OS, VM boundary, and runtime isolation is extremely important. And AKS offers a wide range of capabilities to harden the infrastructure, enforce compliance, and isolate the containers from the host and from each other. So to name a few, we have features like hardened bootstrapping and trusted launch. Secure boot ensure that node starts in a verified and a trusted state. Then FIPS compliance, dedicated host, host-based encryption are all available for your regulated workloads to ensure that there is no external access to the data within your clusters. Pod sandboxing, confidential containers, and user namespaces, they help isolate your workloads from the host and from each other, adding multiple layers of protection to the node layer. We will talk about some of these in detail in the upcoming slides as well. So starting with user namespace, it basically helps isolate container users from the host by mapping a container user ID and a group ID to different IDs on the host. So this means that even if a container is compromised, its user doesn't have any meaningful privilege on the node. And this is a major security hardening feature which is now available in AKS for Linux workloads, which help increase host isolation in your clusters. So containers running with unprivileged user ID or group IDs that are distinct from the host, if a container escapes, it can't access the host resources with meaningful privileges. It also helps prevent lateral movement. So each pod is assigned a different user ID and a group ID range. So even if an attacker is able to compromise one pod, they can't use the same user ID to access other pods. And then we follow the principle of least privilege here, so no automatic host level privileges are granted to the pods. The pods only have the permission it needs within its own namespace. And then you can now securely run any unprivileged container builds inside a pod, like any Docker builds, without giving the container root access to the host. Let's also take a look at one of the most advanced forms of node isolation we offer in AKS, which is confidential VMs. These VMs use hardware-backed memory encryption to ensure that even Azure infrastructure or any hypervisor level components cannot access the data in your workloads. So everything that runs inside the VM, including your containerized application, stays encrypted in memory and protected from access outside the guest OS. With that, we have Azure Linux 3 support in public preview, providing a Microsoft-maintained hardened image for confidential VM scenarios. Then Ubuntu 24.04 is now GA for confidential VMs, so you can use it with the Ubuntu 24.04 SKU, and it will become the default confidential VM image starting Kubernetes version 1.35 as well. So this is especially critical for customers in regulated industries or those processing any highly sensitive data where confidential computing is a key compliance requirement. All right, so we are also introducing a safer and a more flexible way to upgrade the Node OS versions in AKS without needing to upgrade the Kubernetes version. And this is especially helpful during transitions, for example, from Ubuntu 22.04 to 24.04. And I also want to mention that Ubuntu 24.04 is also available in preview. So if you want, you could test this feature out, and also Ubuntu 24.04 and update your node pools to use this newest version. So with this capability, we have this feature flag called OSQ. You can test a new OS version. So if you want to transition your node pools from 22.04 to 24.04, you could set up the OSQ to the updated Ubuntu version and perform the migration without needing to upgrade the Kubernetes cluster. Now, if you want to roll back, you've tested the newer OS version and want to roll back, there's also capability for that. You could use the OSQ from Ubuntu 24.04 to Ubuntu 22.04. And for Azure Linux, we do have OSQ coming soon for you to test the migration from Azure Linux 2 to Azure Linux 3 and back from 3 to Azure Linux 2. So with this new workflow, you get more flexibility, better testing options, and lower risk when managing any OS transitions in production. Okay, so AKS now uses snapshots as part of its Azure Linux OS security patch channel. And these snapshots are tested across environments and across different regions at the same time before being promoted to production, which helps improve the reliability and resiliency of security patches. So with this feature, we're bringing greater visibility or better visibility, reliability, and predictability to how Azure Linux applies security patches and how they are delivered in AKS. And through a soon to be released AKS release tracker, you will also get real-time visibility into OS patch rollout status region by region. So you'll be able to see when a snapshot entered testing, when it's being applied across regions, and which package date is running on your cluster. And this not only improves the trust and observability, but also helps you with any compliance requirements that you may have as to when a certain security patch would be applied to your cluster to fix certain CVEs. With that, we end the node section. All right, so and at the top of the stack, we have the application layer. This is where your code runs, it interacts with secrets and accesses data. And this layer is a key part of your attack surface, and AKS provides several tools to protect your applications using some of these capabilities that we've listed here. So For example, workload identity allows your applications to access Azure resources securely using federated identity from Kubernetes. So, no more secrets that are stored in the code or any like mounted credentials. Then secret store, CSI driver that integrates well with the Azure Key Vault, so your apps can mount secrets as volumes at runtime, and it also supports automatic secret rotation. Pod security admission, which basically applies the pod security standards, which is the native Kubernetes security best practices to ensure that your application deployments are following security best practices that are laid out as the pod security standards. Customer managed keys lets you encrypt application data using your own keys in Azure Key Vault. This helps meet compliance or data governance requirements that you may have within your organization. And then application level vulnerability scanning. So, your container image uses multiple dependencies to make up or to build a container image. We have multiple layers within the container image as well. So there are capabilities to scan for CVEs in those dependencies as well, giving you that end-to-end visibility into vulnerabilities and the fixes that you need to apply. So the next section we have is networking. I don't know about you, but I think I need a break before we get into networking. So maybe let's head out for the break, refresh ourselves, and then we can get back to networking. Continuing with our layered security model, networking is the final layer in our security stack and is also one of the most important to get right. Even if your workloads and identities are secured, a misconfigured network can expose your cluster to unauthorized access, data exfiltration, or lateral movement. And AKS provides multiple options to help isolate, filter, and inspect your traffic, whether it's ingress, egress, or any service-to-service communication. Basically, networking or AKS networking in general is all about reducing the blast radius. And with the solutions and capabilities that have been listed here, you can enforce a zero trust networking model inside and outside the cluster without compromising developer agility. I'm going to talk about most of these in the next upcoming slides, so not spending too much time here to talk about the capabilities. All right. So network isolated cluster, which is also generally available in AKS, simplifies the process of restricting the outbound network access, basically reducing the risk of any accidental exposure of public endpoints or data exfiltration. Looking at how it basically works, so all system components like the control plane, add-ons, and security patching are all accessed over private endpoints and Azure's private backbone. So there's really no need for internet access or public IPs, even for essential services like image pulls or cluster bootstrapping. So basically, this prevents data leakage by default by denying all outbound traffic unless you explicitly allowed certain access, certain IPs or certain outbound access outside your network isolated cluster. And this basically leverages private link to inject any services or add-ons into the cluster. So basically, as you can see in the image we have on the right, all of the any attempts to pull any images or binaries for the add-ons and services that you want in your network isolated cluster are pulled from the Azure Container Registry instance, which is connected to the cluster instead of pulling those container images from the Microsoft Artifact Registry. And even for cases where the images aren't present in the ACR pulls them from Microsoft Artifact Registry and serves them via a private endpoint to your cluster, basically eliminating the need to enable egress from the cluster to the public Microsoft Artifact Registry endpoint. The OS security patch channel is also fully supported in the network isolated clusters. And basically this gives you the operational benefits of AKS, but with a private network perimeter, tightly control egress, and any zero internet dependencies. Talking about clusters that do require outbound access through a corporate proxy, AKS does support HTTP proxy configuration during cluster creation, but we've now made it more flexible for you to update or disable the support available post-creation. So with HTTP proxy update now being in GA, you can now add or update the HTTP proxy settings on an existing AKS cluster using Azure CLI or ARM templates. There is no need to recreate the cluster. This applies to whether your clusters already has a proxy configuration or you need to add one to your existing cluster. So as an example, you want to update the proxy URL, you can do so with HTTP proxy update. We have the HTTP proxy disabled in public preview. You could also disable the proxy settings on a running cluster, and when disabled, the proxy configuration is retained in the cluster metadata for cases where you would want to re-enable it later on. And after disabling, all of the proxy environment variables are removed from the control plane components, the nodes, and the workload. And this gives you the flexibility to temporarily or permanently disable proxy enforcement. For example, when you are switching to a private networking model like network isolated clusters that we discussed in the previous slide. And at any point, you can re-enable HTTP proxy by updating the cluster with the saved configuration, like I mentioned, and there is no redeployment needed for the same. All right. So encryption in transit for Azure File NFS shares in AKS is also public preview. This feature basically brings enterprise-grade encryption in transit support for AKS clusters using Azure Files NFS shares. It ensures that all reads and writes to Azure Files via NFS within the virtual network are encrypted using TLS 1.3, which is basically adding a strong layer of protection against any sniffing attacks or any tampering. And starting with AKS version 1.33, you can now enable encryption in transit for your Azure Files NFS shares by simply setting the storage class parameter encryption in transit to true. There are also no application changes required. Encryption in transit works transparently. Your existing NFS based applications, they don't need to be re-architected in order to use this feature. There's also, like I mentioned, built-in TLS 1.3 support, which brings stronger encryption protocols to the storage path, especially important for sensitive workloads or regulated environment. And this makes it easy to meet any compliance requirements that you may have within your organization for data in transit without sacrificing the flexibility or performance for your workloads. All right. Next up, talking about incoming traffic to your workloads and pods. So we have secure ingress with application gateway for containers and web application firewall. So when you're exposing your applications to the internet, you need a way to securely handle the traffic, incoming traffic, especially for applications or services that are HTTP based. And application gateway for containers now supports integrated web application firewall to help detect and block any malicious traffic before it hits your pods. So as listed here, it helps protect and monitor the traffic against some of these common web-based attacks like SQL injection, cross-site scripting, HTTP protocol violations, and so much more. And all of this happens before the traffic actually reaches your cluster, reducing the risk and offloading responsibility from application developers. This is extremely critical for internet-facing workloads where you can't fully control the source of inbound traffic. And with application gateway for containers and web application firewall, you get this built-in scalable and Kubernetes native ingress protection without needing to deploy and manage any third-party ingress controller or a web application firewall. All right, so talking about traffic, outbound traffic, or traffic from the pods, static egress gateway public prefix. This feature lets you control which specific pods in your cluster can send outbound traffic using a defined public IP or a prefix. It's extremely useful for securing sensitive workloads that need to connect to external services while keeping the rest of the cluster locked down. So with static egress gateway, you can assign a fixed IP prefix to selected workloads, and only workloads with a matching annotation will route their traffic through the gateway, and all other pods would continue using the default egress path, which can be more restricted. So this basically offers deployment level control, since you are able to scope the deployments or pods that would have access to certain services, and you have the ability to lock down certain deployments and pods to access or talk to the outside world. So this basically offers enhanced security. Pods that aren't explicitly configured to use the egress gateway will not have internet access, which reduces the risk of data leakage or any lateral movement. We also have an example scenario here on the right. So we have two pods running in our AKS clusters. Pod 1 is the payment app for which we have configured static egress gateway, and on the other hand we have the front-end app. Pod 1, the payment app, since it's configured with the annotation, would be able to access an external service. Let's say it's a database, would be able to access that external service through the gateway, whereas the front-end application would be blocked while accessing that service, since it's not configured to use the egress gateway public prefix. So to wrap up, this setup basically ensures that only services that truly require or need egress access get it, and supporting compliance, auditability, and also security for your workloads. Keeping up with the same theme, we also have Istio Egress Gateway, which is now in public preview, which offers more control over outbound traffic from workloads running inside a service mesh. So it is built on the static egress gateway by adding support for layer 7 policies and identity-based rules and namespace level configurations. This is, again, especially useful for clusters where applications don't have public IP addresses. In such cases, workloads inside the mesh cannot reach any external services directly. So the Istio egress gateway acts as a managed outbound path in such cases. This offers you more control since you can apply L7 policies, IP restrictions, and identity-aware policies on outbound traffic, just like you can for ingress. You also have a granular design. You can define multiple egress gateways and deploy them per cluster, per namespace, or even per workload. And this gives you the flexibility while maintaining isolation and governance. So again, there is an example scenario here on the right side. And imagine that there is a payment service that needs to talk to an external API that runs on a node without a public IP. You can define an egress gateway with a public IP and configure Istio to route traffic for that API through the gateway while keeping other services locked down. So as you can see, the example YAML shows how to define a gateway and virtual service that routes traffic to the edition.cnn.com through the egress gateway. Moving on, we also have FQDN-based filtering now generally available. Basically, the FQDN-based filtering lets you control egress traffic in AKS using a fully qualified domain name instead of IPs. So this essentially means that you can block or allow access to specific domains like Microsoft.com directly through the Kubernetes policies. And this feature is part of the Azure Container Networking Service offering for AKS clusters using Azure CNI powered by Cilium. So it essentially simplifies the policy creation and maintenance. You don't have to track changing IPs or maintain a large list of IP allow lists. The filtering uses a DNS-aware logic. When the domain name resolves, the IPs are cached and dynamically enforced in the data plane. And if the domains change, the policy does update without any intervention from your end. And it's particularly useful in scenarios like restricting pod to only access approved external APIs or any internal services. So similarly, an example shown here on the right, we have an egress rule here that allows traffic from backend pods. So from app1 myblobstorage.com using the match pattern field inside the FQDN rule block. And you can define like multiple domain-based rules in the Kubernetes network policy objects, making it easier to secure the outbound traffic at a granular level. All right, last announcement. We also have layer 7 policies in public preview. The L7 policies allow you to enforce traffic control at the application level layer using protocols like HTTP, gRPC, and Kafka. This goes beyond basic IP and port filtering by letting you restrict traffic based on API methods, paths, or message types. And with these policies, AKS users can define which pods can talk to which services using specific HTTP verbs or endpoint patterns. And this essentially helps prevent any unauthorized API access or any lateral movements or accidental data exposure. So essentially, the Layer 7 policies provide you with a granular access control between your microservices or your applications. You can allow only GET requests to certain endpoints or only permit specific consumers to talk to, for example, like a Kafka topic. It also helps enforce compliance requirement where communication between services need to be strictly limited or auditable. And again, an example here on the slide, the YAML shows the Cilium network policy. Oh, before getting into this, again, this is also offered as part of the Azure Container Networking Services offering, available to customers using Azure CNI powered by Cilium. Getting back to the example, like I was saying, the YAML here shows a Cilium network policy allowing only HTTP GET requests to the V2 API V1 endpoint on a specific pod label match. And this level of policy definition is especially valuable in like a multi-team environment where different services expose APIs internally. With that, we've come to an end for securing AKS across the stack. Most of this information we have available in our docs, but if you have any questions, let's connect over lunch. And also, I would like to hand it over to my colleague, Vaibhav, for the next session. Thanks, everyone.